How do you backfill the Spark streaming jobs?
So backfilling the streaming data mostly there is no need to reprocess all the historical data in the streaming fashion. Only the recent records that need to be processed. Like refilling in the sense, let's say a job got failed and we have taken it for debugging purpose to see what went wrong and all those times. So it has taken some time around like 1 hour or 2 hour. And if you wanted to reprocess the data which has produced during this 1 hour, which is nothing but this backfilling the streaming data. So in this case, we can use the same streaming job, but using the defined offset. So we need to pass the offset whether what is the starting and ending offset, and we need to mark the trigger as like once trigger, so that the backfill job is like a one-time job and a batch job that reads the data from the Kafka and process it out and write the data to the checkpoint, and then it will kill. So that's how the trigger one-time job that can be handy in this case. Or we can also use some dedicated batch job. So for that batch job, we need to pass what is the recent offsets and that what is the recent offsets, and it has to read all the data from the Kafka, and it has to process and it will load the data to the downstream application. So once we confirm that everything is good, then we can rerun the actual job to start the streaming from there on. So this is how we can manage these backfilling jobs in the streaming applications.
How do you optimize the Spark streaming job with Kafka source?
So to optimize the performance of the Spark job, first we need to Spark streaming job. First we need to understand the how the data is reading from the Kafka, like how many partitions that Kafka topic has, and what is the input record that Kafka is producing or sending data to the Spark, and how the processing speed of the Spark, like how many records that it is processing per second, and we need to process the delay in the batch running, and what is the time it is taking to process the micro batch job, and all these details we need to observe, and then we need to see is there any delay was happening while processing or while processing, or while reading the message from the data, or while writing the data to the some external sinks. So by looking all these parameters in the Spark UI Spark streaming SQL streaming tab, then we can try to apply the different techniques to read the data from the Kafka. Like if it is an issue like while reading the data from the Kafka, if you feel that it is taking more time and it is reading slowly, better we can increase the parallelism by enabling the number of the partitions, or by reading the data to the different topics and use the number of cores to read the data from the executors, right? So this is how we can manage the loads, and if it is taking the data while processing out, so we need to optimize the Spark job by using the broadcast joins, and by implementing caches, or by using the different methods to optimize the process, and even by loading data to the different things. So we should see how we can able to improve the performance of the job, and overall we need to completely monitor the system and the job performance over a period. Then we'll understand what is the latency and where it is actually causing an issue. So by looking at the issue, we can apply the fix. So that's how we can improve the performance of the streaming job in.
Spark has 100 cores and Kafka topic has 20 partitions. How many parallel tasks can be used to read data from Kafka?
Okay, so let me understand the question. So we have a Spark job and it has with 100 cores, and Kafka topic has 20 partitions. So when we subscribe the Spark job with the Kafka topic, so how many parallel tasks that it can be used? So mostly for the Kafka and Kafka topic and Spark task will be like one-to-one mapping. So mostly here in this case it should use the minimum number of partitions or minimum number of cores that will be available. So whichever is lesser, it will take that account, and those many parallel tasks it will be executed. So in this use case, so it will create 20 parallel tasks that will connected to each partition in the Kafka and start reading from the data. So though Spark has like 100 cores, it will use only only 20 cores to read from the Spark, and remaining all 80 cores will be ideal. So that's how the Spark can work. If you wanted to utilize all the 100 cores, maybe we can distribute the data to the multiple. The first thing is uh, we have to create the Kafka with 100 partitions, or we have to load the data from the existing Kafka topic to a different topics with more number of partitions, like 100 partitions.
What is checkpoint and what are all information will be stored in it?
In Spark structured streaming, so checkpointing is an important topic that ensures the fault tolerance, and it provides reliability and ability to recover from the failures. So it is actually a process to store the state of the information of the streaming job of each micro batch job to some persisted location like HDFS or S3 as like persisted location. So checkpointing has a multiple purposes. Like it is used for the fault tolerance, like it allows the streaming job to recover from its failure without losing any data. Like if any job fails, Spark use the checkpointing data to restore from its previous state to build, and then it will continue the operations from there it will left on. And the state management, so for stateful operations like aggregations, joinings, and other operations, the checkpointing stores the intermediary results which are essential for managing consistency across the micro batches. And it also uses for the metadata storage. Checkpoints also store the metadata about the source and offsets information message already processed from the Kafka, and other details. And the information that's stored in the checkpoints are like, first thing is a offset. So offset, once the Spark job read and processed all the information as part of the micro batch job, the offsets information details will be stored in the offsets folder. And the state information, so for stateful transmissions like aggregations and current state of these operations will be saved under this folder. And this will allow Spark to rebuild the state for every next micro batch job, and then it will start executing the job from there on. And also it can store the streaming query metadata, like information details about the streaming query, including its configuration, execution details, uh, all the information that will help to resume the query accurately. And batch processing information, like it stores all details about the current batch, like all the details about the micro batch information, what details that it processed, how much time it has taken, and all the details it will be stored. The next thing is the schema information, like what is the schema of the data and how we have processed, and all that information, that lineage information and all will be maintained as part of this checkpointing. So to enable the checkpointing, we need to give the checkpoint location while writing to the write stream, and the checkpointing location we have to mention, and it is mandatory. So for each query we have to define one checkpointing location, that is a persisted location, where it will keep adding the persisted or checkpointing information to the persisted location.
How do you stop the Spark streaming job gracefully?
Okay, so let me understand. So submitting the Spark structured streaming job in a graceful manner is like, it should not stop the job in between the processing of the data. Instead, it should stop the data in between the two micro batch jobs. So when the job was not processing anything, it has to stop. So that is nothing but a streaming job graceful shutdown. So to do this one, we have to use this stop method on the shutdown hook. Like we have a stop method that was available in the Spark streaming context, so we need to use that method. So to use that one, we have to use, like, Spark streaming context. So in the streaming context thread, we can use this function like ssc.stop, and Spark context should be drop, and stop gracefully should be equal to true. So if you can keep this one, whenever it receives a shutdown signal, it will complete the current execution of the batch job, and then it will terminate. So this how it will work. And also we need to pass this configuration as part of the Spark submit, like Spark streaming dot stop gracefully on shutdown equal to true. So this also behave in the same way. So we need to handle it in the code as well well as in the configuration. So that is a one thing. And the second thing is by using an external control mechanism. Let's say we can keep some file in some dedicated directory, and once it has start the streaming session, we need to write down the code. In that code, it has to check in the you know iterative loop, indefinite loop, to check whether the particular file was existed in the directory or not. If it is, if you wanted to terminate the Spark job gracefully, you can delete the file externally. So once it is deleted, it will check that location and it will mark the flag as like it has deleted, so that the Spark context stop command or method will be executed, so that the job can be exited gracefully. So these are the methods. Like basically we can use this Spark context that stop method to stop the job gracefully.